So I'm just looking at this door group, and I feel like this piece here shouldn't be in the door, part of the door group. That looks like, you know, the kind of, I don't know, the shelf kind of surface, you know, where you might step on to get into the car. So I'm just going to remove them. So just come back here, click on this triangle, and then control and click to remove from the selection. It's still, you know, we're still doing this by class. Just press enter, and that will remove that from that section there. Okay, and that will filter through all our constraints here, ignore that. And then all the way back down to here. So now let's give this a color as well, why not? Just select the box, make that purple, or whatever color you like. Now let's start adding the constraint properties to these, all right? So we've got RBD constraint properties. And let's start with these constraints, so connecting this piece to the body here. So they're going to be the connectors, rig to bendy. Right, we can give them some fancy color, whatever you want. And they're going to be glue constraints, and the strength is going to be -1. Okay, and the rest can be, so if you set this strength to -1, they will never break, basically. Okay, they're like hard set. They you know, they'll never break. Okay, it's like infinite strength, I suppose. Cool. Let's copy this down. What else do we want? So we want the bendy constraints, so the actual metal. Okay, we'll give them a different color, yellow. It's just for visualization purposes. They're going to be glue. They're going to be quite weak. That will, you know, I want them to be able to break pretty easily. I want a lot of propagation iterations, so that, you know, when they break, the impact spreads along the metal. And I do want to switch constraint types, so when they break, they become soft constraints. And they're going to be quite stiff with a high damping ratio, so not a lot of bouncing and you know, wobbliness, and with an angular stiffness. I'm going to change that damping ratio to 10 also, right? So I don't want them to be bouncing around crazily. And we did use plasticity in the last lesson, you know, with the bus shelter, but we're going to do this one in a bit of a different way. We're just going to be switching this back to a glue constraint after a bit of time. Okay. What else? Let's do another constraint here. Let me just drop these down to separate the two kind of blocks. So change the color to this, and this is going to be the spring constraints, so connectors, door not door. Okay, so these ones up here, and also I want the suspension to the hub. Okay, so these are going to be the, you know, the spring constraints here, or soft constraints, sorry, and they need to be very stiff, so I'll put that to 50, and I don't want too much damping on this. Okay, I don't want it to be super springy. Well, you know, I want a sense of weight for the car, so that, you know, it bounces a bit, but not, you know, like a cartoon. And that's fine like that. Okay, now I'm just gonna drop this at the bottom there. We're going to be packing this up in a moment for a reason that I will explain later. Okay, and then I want to do some more work on the constraints. So yeah, you might notice we don't have properties on the, you know, the suspension or the spinning parts of the wheels and stuff like that. There's also a few other things I want to do. So I'm going to group a section of these constraints that, again, I'm making the kind of part that I want to simulate smaller yet again, similar to what we did before, but now I'm working on the constraints. You know, you can use either or system or both. So I'm basically going to make a selection, and everything outside of that selection, the constraints are going to be infinitely strong, so they'll never break, right? So we're going to be doing that on primitives, again in bounding region, bounding box, and again I'll just type in the values. Okay, 1.5 there, and then what do we have here? Minus 0.5, 0.5 there. Okay, and you can see I'm just kind of selecting this square around the door. Okay, and then let's start dropping some wrangles here to add some properties on the primitives. Typically, I think, yeah, basically all constraint attributes are saved on the primitive. Okay, so it's important to remember that. So I want this to be not on the weak constraints and not on the connectors, any connectors. So I'll just do, I don't want these values to be applied to the weak constraints. So I'll put a not there and a not for these. Okay, and then the strength is going to be -1. Okay, so everything outside of this box, and you know, not all the connectors, because it shouldn't matter, but just in case the setting those attributes, you know, confuses the constraint. And just to double check that we're doing this correctly, we can just add a color. CD is we'll do it like this. Set, just make them red. Hopefully we should see that. Okay, so everything outside in red is not going to break, and that's perfect. So we also need some cone twist constraint properties. So that's going to be for the between the rig and the hub and the wheel itself, right? So we'll set them up here. So let's give these a name. Find the groups. So we want connectors wheel to hub, yes, and connectors rig to hub. Perfect. So they need a constraint name. I'm doing this here because basically it's not an option in any of these, right? We only have soft, glue, and hard, so we just do it ourselves, which is fine. Maybe they'll add the options in the future. This will be called cone twist. Okay, and the constraint type s at constraint underscore type is all. Okay, because you can just constrain the rotation, and you can constrain the position also, but I want to do both. So just like that, that's perfect. Oh, I got a mistake there. Oh, I see. Capital S there somehow. There we go. So that, yeah, these spaces shouldn't matter in Vex. Cool. So still not done with these. Let me just change the names here. Strong section. And this, let's see, cone twist. Okay. Now, yeah, with cone twist constraints, we need them to have a 0 kind of length. So you'll see what I'm doing now. I'm going to use this facet and just turn on unique points, and that's basically going to separate, because we're going to have constraints that are connected in the middle, and I want them to be their own kind of island, you know, each primitive to be its own thing. Maybe we can see it if I do an exploded view. Let me see if I turn that off, you can see the lines there connecting in the middle. So I want them to be separate, right? But not all of them. So I just want the cone twist constraints. So again, connectors wheel hub and connectors rig to hub. And then so now they're separate, and now that I have them separate, I want to make them very small. So basically get rid of the length of the primitive. So if we just drop a primitive node, go do transforms and set the scale to 0, that just turns them into and source group. Make sure that we do the same groups again. I'll just copy them from here. Don't forget to do that, it's important. Okay, and then you'll see, you can see them disappear, but they are, it might be hard to see in this kind of maze, but they're being reduced to a single point. So there's one there. You can see it's just a point in the center now, and there'll be another one here. Okay, so there'll be 2 points there, I think, if we look at the values. Yeah, you can see that the two numbers kind of overlapping. Okay, and that is just the way that cone twists work. They'll work better and more predictively this way. Another thing I want to do, we need to add some more attributes here. So connect it from the suspension to the hub. So that is these constraints. I want the rest length to be a little bit longer than what it currently is. Okay, so the rest length is just how long is the constraint. You know, how long does it want to be, and you know how long it wants to be is how long it is right now. And if I multiply that by 1.1, it's going to try to achieve a length which is 0.1 longer than what it is right now. Okay, so if you think about a car and sitting on springs, those springs are going to be under stress, under tension. They're going to be compressed from the weight of the car. So when the car is lifted, you want those strings to expand and push the wheels down a little bit. So that's what this should help do. Another thing, so a few wrangles here that we've got to do. So the constraints from the middle of the car to the hub is where we're going to get some movement, allow some movement of the wheels up and down and back and forward. Okay, again, did I set this to, you can see I'm making the same mistake myself. Primitives there on the wrangles, always remember to do that. Okay, and I'm going to set this onto the rig to hub. I have to do it out here because I need different values on different cone twist constraints, right? So this is going to be a float value. And by the way, these are attributes that are pre-named. They're pre-known by bullets, right? They're not attributes that I'm inventing. Rotation. So the outer rotation is going to be 5 degrees. I think it's in degrees. So that's how much the constraint can move. Back and forward is 5 degrees. Okay. And then we have the up rotation is also, I'm going to leave that at 5. Okay, so up is up and down in this direction. And I also want to have f at max underscore twist. So that's pretty self-explanatory, is how much it can actually rotate around its own axis, right? So allowing the wheels to spin. And we set that to 180, will allow it to spin all the way around 3. I know it's kind of strange. You set it to half, but that's how it works. Okay, and then I need to do the same thing again because I don't want these values, because we don't have the values on the other cone twist constraint. So just to be safe, on the wheel to the hub, where is it? Wheel hub, because I don't want that constraint to allow the wheel to move up and down. I want that to be only on one constraint. So all the same, except for this part, which would be 0 and 0. Okay, so let's see. Let's do suspension there, and then these. Let's just call these cone twist props for both. Okay, so I think that's all pretty much done. Let me just connect that up back to the middle there, and that's our constraints ready to be simulated.